Hello and welcome to Chapter 1 of the Operating Systems course. We are going to talk about the 4 different objectives that we are going to cover during this session. The first one is what is an operating system and what is its basic role. 2 is why should we study operating systems. 3 is how operating system software works at a high level. And number 4, how operating systems have evolved through the decades. If you pay attention to the sequence that we are going to follow, we are going to answer the what first, the why second, and the how last. We are going to start with what is an operating system. It's a layer of software that provides 2 major attributions or characteristics, and those are abstraction, number 1, and arbitration, number 2. Abstraction is the attribute that allows the operating system to be kind of the middleman between the hardware and the software applications. So if you take a look at this layered approach of the computer system, you're going to see 4 different layers. The first one being the hardware, which is the one that I am highlighting here. And then the operating systems comes next. After that, the libraries and utilities, and after that, the software applications. So for the hardware, you see the processor being one of the main components of the hardware, the memory being the second main component of the hardware, and the input and output devices being the last major component of the hardware. Now, the next 3 layers in the diagram that I am showing you now become the software portion of the computer system. And within the software portion of the computer system, there are 3 sub-layers, and those are the operating system, libraries and utilities, and the software applications. Now, the last 2, the libraries and utilities and the applications, are part of what I call the software in the user space. By that I mean they are either part of the application, the software application, and I can give you examples. Adobe Reader, for example, is one of the applications that you are familiar with. Microsoft Office, by that I mean Microsoft Excel, Microsoft Word. Those are applications that reside in this top layer that I am describing here. So those 2 layers are part of the software in the user space. The examples that I gave you are part of the software applications. Now, there is another component that is called the libraries and utilities, and those are part of the operating system. However, they are not part of the kernel, which is the core component of the operating system. So the libraries and utilities become what is called the other part of the software in user space. And the utilities are, for the most part, a utility program is a type of system software that assists users with controlling or maintaining the operation of a computer, its devices or its software. Utility programs typically offer features that provide an environment conducive to successful use of application software. For example, utility programs protect a computer against malicious software, malware, viruses. So when a program that acts without a user's knowledge and tries to alert the computer about the presence of malware, that becomes a utility program. A library program, on the other hand, is the collection of non-volatile resources used by computer programs. Library program is a program that has a collection of code used by the application. So it is a set collection of code that programmers can use as part of the use of software applications that they develop. So that is not really a part of the kernel within the operating system, which resides in this green section that I am pointing at right here. So this will become even more important when we talk about Linux later on during the course, because the different flavors of Linux may share this section, the green section that I am describing here, but they do not always share the yellow section, which is the one that I am pointing at right now, the libraries and utilities. So the different flavors of Linux will become really important for us to remember when we talk about operating system and the libraries and utilities, because this yellow section will differentiate between the different flavors of Linux and Unix that we are going to talk about. Again, the operating system is the layer of software, because all of these three layers are part of the software component of a computer system. The operating system is the layer of software that allows the communication between the hardware, which is on the bottom, and the applications that are on top. One more component, and that's the kernel that I was telling you about that resides in the green section of the operating system. One more component that I want to make sure that I highlight to your attention is the users. The users are the ones that are in front of the computer system utilizing these 4 different layers that make up the computer system. So for the user, the layered approach of what I described to you is transparent, meaning they do not really understand what is behind the computer. However, the explanation that I gave you will allow you to understand what are the components of the operating system and how they interact with each other. So the next question that we need to answer is, why should we study operating system? Why don't we just sit down in front of the computer and then make use of the computer without even worrying about how those computers work? Well, the answer is as follows. You are, for one reason or another, going into the technology field, either as a programmer within the programming program, or within the networking program, or for the future students that are joining the cybersecurity program for the cybersecurity needs of understanding how operating systems work. So studying operating systems and the way that the operating system interacts with the hardware and the applications will help operating system designers, in this case, you can include programmers in that bucket, envision their role and plan their work, meaning they will be able to understand how the code in their programs will interact with the operating system by understanding the basics of how an operating system works. On the other hand, network and security professionals identify security vulnerabilities in operating systems by understanding how the operating system communicates with the hardware and how the operating system communicates with the software, the applications, so they can create security controls against the vulnerabilities that are discovered in the way that the operating system is working with the other components of a computer system. Now, the next question that we need to answer is how operating systems work. The management of 4 essential managers or subsystems is one of the main components of how operating systems work. The first essential manager or subsystem is what is called the processor manager. So it's the capability of the operating system to handle the CPU or the processor in your computers. The operating system has to be smart enough and capable enough to manage how the CPU is used by the software applications that reside on a given computer system. Now, the next major essential manager or subsystem in an operating system is the memory manager. The memory manager is a subcomponent of the operating system that allows the operating system to manage the resources that are available as far as memory within the system. So as you know, your computer may have either 4, 8, 12 or 16 gigabytes of memory, for example, RAM in your hardware. And the operating system that you have installed on that computer that you are using is able and has to be capable of managing the resources, the memory resources that are available to the computer that you are using, either 8 gigabytes, 12 gigabytes, or 16 gigabytes of memory. So that is the component of the operating system that is responsible to allocate memory to the different programs that are in use in your computer. Now, the next essential manager or subsystem in an operating system is what is called a device manager. And the device manager is responsible to manage devices, meaning the keyboards, the mice, the printers, any USB device that you connect to your computer will be managed by the device manager. And next comes the file manager. So in your computer, most likely you have a set of files that are part of any applications that you use and files that are created by you as the users. So those, the responsibility of managing how those files are provided to the user in the form of the visual graphical user interface, though that is a responsibility of the file manager. Now these 4 different managers, major components, essential managers or essential subsystems of the operating system, interact with each other very closely because they need to share responsibilities, they need to communicate with each other, they cannot work alone, they work in conjunction. In order to give the user who is in front of the computer the user experience that you guys get when you are accessing your computers. So again, processor manager, memory manager, device manager, and file manager, no single manager performs tasks in isolation. The user interface is the portion of the operating system with direct interaction with the users. 2 primary types. You may be more familiar with a graphical user interface and you may like the type of presentations that I show to you because they are very dynamic as far as the colors and the design and the graphics. I really like to, I enjoy creating the presentations in a way that are visually attractive. So that is part of the graphical user interface of an operating system. Now, when you're talking about operating systems that are command line interfaces, you lose the capability of show graphics, for example, and you get into a view of a, what I call, and let me see if I can access that from here. It is the Linux type of interface that you will find when you are accessing any type of Linux flavor. So they are typically based on what is the command line or the command prompt for Windows users. In the case of Linux, for example, the emulator is the one that you may be familiar with. The terminal emulator is the one that is used by Linux, and they don't provide you in most cases with a graphical user interface unless you install that graphical user interface for Linux. But Linux systems provide you more with a command line interface that you need to master in order to make the computer do the type of work that you need. So the processor manager again is the subsystem of the operating system, is a component of the operating system that manages the CPU. It is responsible for the allocation of central processing unit, tracks process status, programs instance of execution. It is comparable to a traffic controller. When a process is finished or maximum computation time expired, the processor manager within the operating system reclaims the CPU and allocates the resources of the CPU to the next waiting process. A computer with multiple CPUs is able to do more, so it requires a more complex management. The memory manager comes next, and now we need to talk a little bit about RAM and ROM. We are going to expand more into RAM and ROM once we get into the chapters of our course that are dedicated to the memory manager. But for now, you need to know that the memory manager is responsible for main memory, the random access memory, the 8, 12, 16 gigabytes of memory that you may see on your computer when you are checking how much memory you have on a computer that you are using or that you are planning to purchase. It requires constant flow of electricity to hold data. So whenever you shut down that computer, whatever existed as far as data in the RAM disappears, because as soon as you remove electricity from the RAM, all the data is gone. Responsibilities of the memory manager are as follows: checking the validity and legality of memory space requests, reallocating and deallocating memory to make more usable space available, protecting space in main memory occupied by the operating system, because imagine if an application is becoming a little bit disruptive to the operating system, then not only the application will crash, but also the operating system will cease to work as expected. So that is why the memory manager is responsible to try to prevent software applications or programs that you're running on your computer from damaging the way that the operating system, in your case it may be Windows, it may be Mac OS, is working. And then the read-only memory, that is the one that holds the firmware, the programming code, and this is the non-volatile memory. Why is that? Because whatever is in ROM, in ROM, resides in ROM regardless of whether or not the computer has electricity coming in, meaning it's turned on or not. So when you boot up your computer again after a long time of being shut down, the instructions that reside in this part of memory, the ROM, will not go away. So your computer will know how to go through the boot up sequence without you having to do anything. Imagine if those instructions were in the RAM, which requires electricity to work, then the computer will not be able to boot up because it doesn't know what sequence of steps it needs to take in order to boot up. So the main first instructions of a computer in order to boot up reside in the ROM. Device manager is the next major component that we discussed a few minutes ago, and that's the one responsible for all the management of the peripherals. So it is in charge of connecting with every available device, printers, ports, disk drives, etc. The responsibilities of the device manager are as follows: choosing most efficient resource allocation method based on the scheduling policy, identifying each device uniquely. So it has to understand that if there are 2 USB drives, for example, connected to your laptop, and that is the case for me, it needs to identify which one is which and be able to save files in the right device based on the user input. So the device manager is the part of the operating system. Again, we are talking about components of the operating system that is responsible to identify each device uniquely. Starting device, the operation. So when the computer is booting up, the operating system is responsible to start the device that is part of the sequence that you as the user, or perhaps the software that installed that device, is responsible to allocate for that device. So the device manager is the part of the operating system that will start the device when instructed. It could be at boot up, or it could be per the request of the user. Monitoring the device progress, meaning whether or not the device is online, offline, whether or not it is correctly connected, whether or not the device is functional. And then deallocating the device. So whenever you, for example, remove a USB drive, if you don't know, you're supposed to go through the function of the operating system and right click on the USB drive that you're trying to disconnect before pulling that out of your computer, either a desktop or a laptop. So it is recommended for you to eject the USB, so you're not damaging the data that resides in the USB. And that will be a deallocation of the device in the case of that USB drive. The next component is the file manager, and that is responsible for all type of files, not only the ones that you create as a user, but the ones that are installed on your computer by the installation files for any software that you install from the website, from any website, or from a CD, even though CDs are not very common to see nowadays. In charge of tracking every file in the system, so that is one of the responsibilities of the file manager, and by that again we are talking about data files, program files, compilers, application programs, and more. Responsibilities: enforcing the user program resource access restrictions. It uses predetermined access policies, controlling user program modification restrictions, read-only, read-write, create, delete. So all those instructions that you put on any file, for example, if you do not want a file to be modified and you make it a read-only, then the file manager, part of the operating system, will be the one responsible not to allow for any user, perhaps not even you, to make any changes to that file because it is a read-only file. Allocating space for a file on secondary storage, one large storage area or smaller linked pieces, and retrieving files efficiently. So the performance of the file retrieval will be one of the main responsibilities of the file manager. Again, a component of an operating system. So operating systems and associated platforms. Here you will see a table that is given to me by courtesy of Cengage. This is the only element practically from the textbook that I am using for my presentation. So the platforms that are listed here on the left and the operating system that is typically found on these platforms, you have the laptops and the desktops, and the operating system that is commonly used are the Linux, Mac OS X, Unix or Windows operating system. Mainframe computers on the other part use typically Linux, Unix, Windows, IBM, z/OS. Supercomputers typically use Linux or Unix. Telephones and tablets typically use Android operating system, iOS. You guys are familiar with that for the Apple phones, and Windows. And the workstations and servers, those are the desktops and the servers that you find in companies, typically use Linux, Mac OS X server, Unix, and Windows. The types of operating systems are classified as follows: batch, interactive, real-time, hybrid, and embedded. So here you will see a little bit of the sequence of events. Disregard this note here. A sequence of events that took place in the last few years. Actually, this is not the right slide. This is the one. So the operating systems and the dates that are associated with the evolution of the operating system. So for example, you have 1950s being the date when the computer operators, to facilitate machine operations and job scheduling, so that the computers in those days, in the 1950s, required the use of computer operators, people actually dedicated to facilitate the computer to work. It was not automatic. It required manual intervention from a person in order for the computer to do something for you. It was very expensive to operate a computer in those days, so that is why it is a characteristics of the computer that was used in the 1950s. In the 1960s, on the other hand, multi-programming came into effect. Several programs were able to load on a computer and share the resources given by the CPU. So this was a major development in the 1960s. In the 1970s, on the other hand, you had a little bit of faster CPUs, nothing compared to what we have now, of course, but it was faster than in the 60s. There were some problems with slower input and output devices that were not able to catch up with the faster speed of the CPU, even though it was not really fast. But the devices, the input-output devices, were not able to catch up. So the main memory physical capacity limitations was another characteristics of those days. In the 1980s, on the other hand, more flexible hardware came into availability. The OS functions were made part of the hardware, and that became the firmware. And another characteristic of the 1980s, as far as the computers that were in use in those days, was the multiprocessing. In the 1990s, the demand for internet capability came into light. The internet was becoming a little bit more famous, more trendy, and the CPUs and the hardware and the operating system that came with it needed to be able to utilize some of the features that were available via the internet, via the browsing of the internet. So that required increased networking capabilities for the operating systems, increased security demands, because now you were opening the doors to sharing resources with other users over the internet, even though it was really archaic. It was not really the type of sharing that you see over the internet nowadays. And multimedia was making its appearance in those days, in the 1990s, in the form of music videos that you can play on your computer. It was pretty cool in those days. So that was a major development in the 1990s, being able to see live music and people playing instruments over the internet, or videos that were played over the CDs and DVDs in those days. In 2000, in the years, the first decade of the 21st century, the need for improved flexibility came into place. The appearance of virtual machines for the first time came into play, and the operating systems needed to be able to adjust to those demands of virtual machines. And then in the last decade, from 2010 to 2020, the increased mobility and wireless connectivity came into effect. So now you had a more mobile workforce, and even for personal use, the expectations of people were that their mobile devices and the associated operating systems were able to handle the mobility demands that those devices had. And multi-core technology came into play, a single chip equipped with 2 or more processors. So that describes at a high level the sequence or the evolution of the operating systems across the last pretty much 70 years. So as a reminder, this is the course map that I mentioned to you in my first video that I was going to reference again and again. What you guys have watched just now is the summary or high-level overview of Introduction to Operating System, which is the one that you see right here. Next week we are going to move quickly to processor management. We are going to stay in processor management for a couple of weeks, most likely. And then after we are finished with processor management, which is, again, you learned it from today's presentation, is one of the main essential elements of an operating system, we're going to move to the next essential component of an operating system, and that is memory management. And then we're going to go to device and file management and system security and management as well. We're going to touch a little bit on networking concepts, even though there are other courses that are more geared towards talking more about networking. So we are going to do that briefly. And then we are going to move to Windows, Unix, Linux, and Android, and how those major operating systems apply the concepts that we learned as far as the management of processors, the management of memory, the management of system security, the management of devices and files. So we are going to apply the concepts that we learned from 1 through 5 to each of the operating systems, starting with Windows, Unix, Linux, and Android. So for now, this is it. I thank you very much for joining. Until next time.